Hello, Maurieos! Land Survey 1, EDM 0 Prism constant. Question 5 from the 2015 Semester 1 exam. Alrighty. Right. I have been asked by a couple of students in preparing for the 2017 exam to have a look at this question, as we have not gone into it in depth in our studies of surveying in this semester, which is a fair comment from the students. And so I've decided that I'll put this video together by way of explaining the teaching methodology that I use is such that students do need to seek out the knowledge rather than see myself as the oracle. I feel that they get a better grasp of the concepts and a better overall understanding if they seek the knowledge themselves and cement it within their own circle. So I'm very pleased that the students have asked me to go over this question and to explain it, as it is exactly the sort of what I'm looking for, and I wish that I could get more of these questions from students, as it gives them a little bit of skin in the game, so to speak, and we can deal with it. So let's just have a look at get the question. So this is the blank question here, and I've put up beside it the actual model answer. So let's have a let's go put that on the big screen so that we can actually see it in some detail. So as you can see there, I'm using oops, that didn't work. Can we get it back to the I thought there I could be a bit clever, but apparently not. So and then we'll go Control 0, which gets it back. Okay, so hopefully we can all see that there. So the following horizontal distances are I'll just see if this here's in the zone as well. Okay, oh, there it is there. That's better. Okay, the following horizontal distances were measured to establish the correct Prism constant. Calculate the correct Prism constant and true horizontal distances from A to B and B to C and A to C. Then check your answer. B is on the line between A and C. So the current Prism constant is 0.03. The distance from A to B, these are measured distances, is 52.174, and the distance from A to C, 101.329, and the distance from B to C, 49.126. So if we think in terms of the Prism constants, each measurement has one Prism constant included in it, in this case plus 0.003. So this distance here will have one Prism constant, and this distance here will have one Prism constant, and this distance here one Prism constant. However, when we add these two, A to B and B to C, we add those two distances together, we will have two Prism constants. And so if the Prism constant is incorrect, we will get a difference between the sum of the parts and the whole distance, the 101.329. So if we come over here and we see that the distance from A to B, 52, if we go for the sum of the parts, which is 52, I think I might just get my little calculator up here just to further illustrate this this point. So I'll just get my little calculator up. Oh, it fits nicely in there in the middle. So if we go 52.174 plus 49.126, 0.126 equals, that's the sum of the parts there, so we need to go to there, 101.300, that's the sum of the parts. And then if we look up here at the 101.329, okay, which is A to C, so they should be equal, the sum of the parts should equal that. So we get a difference of minus 29 millimeters there. So we need to, that's going to be, we need to go, we're 29 millimeters down. So we need to add 29 millimeters to the 101.3 to get 101.329. So we've got to add the 29. Okay. So that's going to be the correction we need to apply. All right, so if we go A to B, okay, and the new Prism constant, because we've already applied 3 here, so 3 plus that will give us 32. So that's the new Prism constant, okay? But remember that these Prism constants are already incorporated in here. So the Prism constant is 0.029. So we go 52.174. Okay, so if we go 52.174 plus, now this is the correction, we've already got 3, so we'll just go 0.029 equals, oops, all clear, sorry, 52.174 plus 0.029 equals 52,203. So that's the correct distance. And then we've got 3 in there, so that's 101.329 plus 0.029 equals 101,358. Okay, and then we go 40.126, or is it 49.126 plus 0.029 equals 49.155. All right. So they're our new ones that we've determined, and then we check those 49.155 plus 52.203 equals 101,358. Bingo, we've got it. It's all good. So what we can determine from that is that the new Prism constant 0.032. Okay, so let's have a look at the answers. Correct the Prism constant 0.032, and there's our distances in there that we've got, and the check is 101,358. So there you have it. Quite simple. Just to recap, so we have a Prism constant set of 0.003. When we add the sum of the parts and add that to the whole, we find that we've got an error of 0.029, and we need to add 29 mils, which that 29 mils is the Prism constant. However, we already have a Prism constant set in the instrument of 0.003, so the actual Prism constant is 0.032. However, these distances here already have the 003, so we add the 29 to get the true distances, and then we just do our check 101,358 to make sure that the sum of the parts equals the whole. And that's it. That's all you need to do for that question 5. So it's pretty straightforward and some really good common sense there on that one. So there you have it. That's that question 5 done. I really appreciate someone asking me the question, so I had the opportunity to go through this and get this sorted. That will be pretty good for those students studying for the test this year, and as we've got this recorded on YouTube for the future. So thank you, Cheers. See you.